Hi, this is a review of Unit B, Chemistry for Grade 9 Science. A lot of the stuff that I'm going to be taking was from a study guide that I found online. And it's really good stuff, and if you're listening to this and you're in my class, the study guide is up on Google Classroom for you. I'm not going to spend a lot of time talking about this part, but part of chemistry is always it's always important is safety. So we have the WHMIS symbols, which is the Workplace Hazardous Material Information Systems, which are symbols that have circles around them, and they tell you what a danger might be in using a certain chemical. And they have undergone some changes, but for our purposes, we don't have to worry about them. We're going to use the old symbols. The MSDS stands for Material Safety Data Sheets, and those are sheets that tell you everything that's important to know regarding the safety, use, precautions, chemical compound makeup of whatever chemicals you're using. And of course, there are the safety symbols that tell you the degree of danger. So dangers in an octagon, cautions in a triangle, for example. But I'll let you guys review that on your own. Okay, so we need to differentiate chemical versus physical properties. This is a really nice chart that does it really well. So a physical property is something about matter that you can observe, or you can just measure it without changing anything about the actual substance. Okay, so some examples of physical properties include the color, molecular weight, um, the volume, the taste, the crystal shape, melting points, boiling points, stuff like that. Stuff that you can actually observe, right, or measure, but when you're doing that, you're not changing anything about the actual chemical. Okay, so if I measure the boiling point of water and I know that it's 100 degrees Celsius, I'm not changing anything about water itself to measure a physical property. A chemical property, on the other hand, can only be observed by changing the chemical identity of the substance. So chemical properties, you have to test them in the lab. Okay, so does it react with water? Does it react with air, with oxygen, with acids, with other pure substances? How toxic is it? How stable is it? Does it burn easily? Those are chemical properties. Okay, so if we're talking about physical properties and we're talking about chemical properties, we have to differentiate between physical changes and chemical changes. So a physical change is just a change in a substance without changing exactly what it is. If I have water, okay, and I boil it so that it becomes steam, a gas, it's still water, it's still H2O. There's nothing about what I'm doing that's changing the molecular makeup of that molecule. It is still H2O. On the other hand, a chemical change, okay, causes one or more new substances, okay, and the properties of this new substance are entirely different than the original substances that we used or that we had, okay. And a good rule of thumb is you can tell that it's a chemical change because if you want to reverse it, it's very hard to do, okay. So like burning paper. If you burn, this is a great example. If you burn paper, good luck trying to get it back to its normal state. Okay. So again, this is something that I've noticed that some students had problems with, differentiating chemical changes and physical changes. So we need to look for the evidence of a chemical change. I have noticed, and I'm happy to say for at least my students, as the year went on, they got a lot better, like at understanding when you have evidence of a chemical change. So I'll just read these out. The first one is heat or light energy is produced or absorbed. So a good example is when gasoline burns in a car engine, heat is released. Okay, and that's called an exothermic reaction. When you have a change in color or a change in odor, okay, you have a formation of a solid. Fancy word for that is precipitating. So if we add a chemical called aqueous silver nitrate, so it's just this chemical silver nitrate in water, okay, if we add that to potassium chloride, we get the formation of a white solid, okay, which is silver chloride. That's evidence of a chemical reaction. And the one that we're all very, very familiar with is the formation of gas bubbles. Okay, classification of matter is also something that's very important for you to know. Matter can be broken up into two main categories, pure substances and mixtures. Pure substances are made up of elements and compounds. A pure substance is only made up of that thing that you're talking about. For example, if I have a glass of distilled water, that is made up of water and nothing else. Therefore, it is a pure substance. A mixture is made up of more than one type of substance. Okay? So the mixtures are, there are different classes of them. One's called a colloid. Okay, the colloids are a cloudy mixture whose parts cannot be easily separated. Solution, homogeneous mixture. Different substances are not clearly visible. It appears only as one substance. So a good example of homogeneous mixture would be salted water. Then there's the mechanical or heterogeneous mixture. So a really good example of that is vegetable salad, or a cookie, for example. That's a mechanical mixture. Suspension is just the substances are easily separated. Okay, the next important topic to discuss is the periodic table. Okay, so you do need to know the origin of the periodic table, and essentially you need to know this guy's name, Dmitry Mendeleev. Okay, and what he sought out to do is just explain the relationships and patterns that exist among elements and their properties as well. He noted that there would be newly discovered elements and left space in his table. So he did some more experiments, and eventually he filled in a lot of the gaps. And when they were fit in, it just went according to his predicted patterns. So a couple things you need to know. Anything going across this way, okay, going across this way, are called periods or rows. And they indicate how many electron levels, shells, or orbitals that exist in that specific element. Okay, groups or families go up and down. Okay, and they're columns. And what the vertical columns indicate is they tell you how many electrons exist in that last electron level, shell or orbital, whatever you want to call it, of that specific element. Elements in the same groups or families share similar chemical properties. That's why they're called families. For example, the halogens are all in group 18, and they all share the same chemical property, or very similar chemical properties. Namely, these guys are not very reactive at all. Okay. The first two elements, hydrogen and helium, hold a maximum of 2 electrons in their first shell. For elements from 3 to 18, which you need to know, lithium to argon, the electrons fill the first orbital with 2 electrons, and then they're going to distribute the remaining electrons in progressive shells or progressive orbitals, holding a maximum of 8. Okay? Important trends that exist in the periodic table. First of all, you need to know, what I'd like you to know for sure is the staircase. Okay? So this staircase is important because it separates the metals from the non-metals. Anything to the left of the staircase. Okay, so in this area here, okay, to the left of the staircase, this area here, everything here, okay, they are metals. Okay, oh boy, okay, they are metals. I cannot write with this mouse. Okay, anything to the right are non-metals. Okay, and then we have another section of the periodic table around the staircase that, you know, in the transition sort of piece here, there are some things that behave as metals and also behave like non-metals. So they're kind of in between. And these are our semiconductors, right? In Unit D of electrical of electricity, and they're called metalloids. Okay, they're sort of like metals, but they have properties of, oh boy, of non-metals as well. Okay, so some trends to understand in the periodic table. In the metals, so in this group here, on this side here, as you go down a group, the metals get more and more reactive. And we saw this in class. Okay, if we put sodium in water, it's quite reactive. But then I showed you a video of cesium in water, and the reaction can be quite explosive. And as we go down, it gets more reactive. In the nonmetals, okay, so on this side of the periodic table, as you move up a group, okay, as we go up, the nonmetals get more reactive. So for example, fluorine is quite reactive, and that's why it's a really good substance to use in your toothpaste to get your teeth clean. As you move to the right across a period, okay, the element becomes more non-metallic, and that just makes sense. So as we go from the left to the right, we're going away from the metals. Okay, we're still metals, but then we're going towards becoming non-metals, right? So as you go from left to right, the elements become more non-metallic. Okay, so there's also some information found on the periodic table that's important, and I'll talk about that on the next slide. Okay, so some important information found on the periodic table, you have to know this, is you'll always find out what the atomic number is, and that's the number of positive protons found in the nucleus of the atom. Okay, and it's also the number of electrons, total number of electrons. So for example, oxygen here has 8 electrons and 8 protons. The negative charges and the positive ones must balance. In other words, atoms contain an equal number of electrons and protons. Therefore, like I said, oxygen has to have 8 electrons. Our atomic mass, okay, is the total number of protons and neutrons in an atom, okay? Not the total number of protons, neutrons, and electrons, because the electron's so small that the mass is negligible. So this mass is just the mass of the protons plus the mass of the neutrons in an atom. Therefore, to get the number of neutrons, okay, you have to subtract the mass, or take the mass and subtract the number of protons, which is 16 minus 8. Sometimes the numbers are equal to the atomic number. Sometimes the number of neutrons are not equal to the atomic number. In this case, they are. Okay, in this case we have 8 neutrons. Okay. What else can I say here? Yes, we have the ion charge. Okay, so when neutral atoms collide, a negative electron is transferred from one atom to another, and both atoms become particles called ions, which have an electrical charge. If an atom has lost electrons, the overall charge becomes positive, and that's called a cation. If it gains electrons, right, it's gaining something negative, the overall charge becomes negative, and it's called an anion. So, for example, if I have sodium, right, and I have an ion charge of +1, that means it's lost an electron. Because it's lost something negative, it becomes positive. Okay? So in this case, how many protons does sodium have? Well, sodium has 11 protons, because if you look at the periodic table, its atomic number is 11. But how many electrons does it have? Well, it's lost an electron because it's got that positive charge, therefore it's got 10 electrons. So the number of protons and electrons helps determine the properties of the element. Okay. Okay, so there are different scientists that have different models of the atom, and one is called the billiard ball model by John Dalton, and he assumed that all matter is made up of small particles called atoms that cannot be created, destroyed, or divided. All atoms of the same element are identical in mass and size, elements can combine together in definite proportions to form compounds. Dalton's model is the basis of today's particle theory. Okay, a couple of other models are Thomson's plum pudding model, and all it is that the negatively charged particles are embedded in a positively charged mass, kind of like plums in pudding. The planetary model by Nagaoka is suggesting that the center of the atom is largely positive and all of the electrons orbit around it much like the sun orbits, much like the planets orbit the sun, or the moon orbits the earth. The nuclear model by Ernest Rutherford takes it a little further. So the mass of the atom is found in the center and is called the atomic nucleus. And very small electrons occupy the remaining space of the atom. So there's a lot of space in Ernest Rutherford's model. Niels Bohr, with his atomic model, says that electrons move around fixed pathways called electron shells. So they have their own spaces, right, and don't kind of overlap each other. Okay, Louis de Broglie and Erwin Schrödinger, two very popular scientists you learn about in high school. They have the quantum mechanical model that electrons have distinct energy levels, and there's an area around the nucleus where electrons are most likely to be found, and that's called an electron cloud. And then there's the current atomic theory. Atoms are electrically neutral because of the equal amount of protons and electrons, and negative electrons are orbiting the nucleus in specific energy levels. Okay, atomic structure. You have the subatomic protons, electrons, and neutrons. Protons are inside the nucleus, electrons orbit, and neutrons are also inside the nucleus. Protons have a 1 plus charge, electrons 1 negative, and neutrons have no charge. So here's the symbols associated with each: P plus, E minus, and 0. And the atomic mass units, that's what AMU stands for. For protons and neutrons, they're both 1, and the electron is so much lighter, so much smaller than any of them, that it's given an atomic mass unit of 0. Okay, ionic compounds versus molecular compounds. You have to know the difference between them. Ionic compounds, the bonds are created by a transfer of electrons. So electrons go from one element to another. And because of that, because there's an actual transfer of electrons, the bond is quite strong. Therefore, it has a very high melting point, and it has a distinct crystal shape. Okay, just think of sodium chloride has the salt has crystals. It's formed from a metal and a non-metal. It forms ions in solution. So in other words, when you dissolve it, like sodium chloride will become Na plus and Cl minus in water. Because it's ionic, it can conduct electricity, and it's a solid at room temperature. Molecular compounds, their bonds are created by sharing of electrons. So it's not that tight of a bond. Therefore, they have a low melting point. And it does not always form crystals. They're usually formed only on non-metallic elements, so everything on the right side of the periodic table, on the opposite side of the staircase. It does not form ions in solution. It usually doesn't conduct electricity. And who knows what they are at room temperature. They could be a solid, they could be a liquid, they could be a gas at room temperature. They're all different.